Okay, students. So let's begin with the final part, that is critical region, okay, which is called as rejection region and which is called as acceptance region. There are two regions, students, rejection region and acceptance region. Even without knowing the definitions, right, you can know what this is. Students, do you know we were talking about this level of significance, confidence interval, saying that this particular value has to come between these boundaries. Okay, if it comes between that boundaries, you accept the value. So that particular region which you have taken, no, is called as acceptance region. If it doesn't come and if it comes outside those particular limits, then it is called as rejection region. That's it. The students understand. But sir, how to decide which is the acceptance region and rejection region? Let us see how to understand and what values to take, students. Suppose for each sample of the same size of a statistic, if it is computed or tested, the value of the statistics which lead to the rejection of H naught gives the region called as rejection region. So what is rejection region? The region where, or it is a space where amounts to rejecting the null hypothesis. If you have to reject the statement you have taken, statement means hypothesis, means null hypothesis. If you have to reject it, that particular region is called as rejection region. Acceptance region, all those values which lie between a particular range, no, that is called as acceptance region. Now, whether to accept or to reject, we need certain value. That value is called as critical value. Critical means most important, significant value. So what is the critical value? It is the value of the test statistic from the sample which separates the acceptance region and the rejection region. On what is it based, sir? It is based on your confidence coefficient or on your alpha, which is called as level of significance. It is called as level of significance. But sir, how do we find out this value, sir? Students, very easy to find out this value. You have statistical tables for this to find out this value. Okay, in normal distribution, no statistical tables. There are fixed values which they have given. Okay, whereas for chi-square distribution, for t-tests and all that, you have different values to take. Okay, for normal distribution sums, you have a particular value, whichever they have given, only that you should take it. We will look into those values in some time for large sample tests. Okay, now two-tailed test and one-tailed test. This I have told you, students, that I will tell it to you showing with some examples itself with the diagrams, but as of now, for the theory's sake, let us see what is it. Two-tailed test means, students, this acceptance region, forget, rejection region is there now. It can come on both the sides. Hope you know how the normal distribution curve is. Bell-shaped curve, sir. Bell-shaped curve. Middle there is mu mean. This side also there is infinity. This side also there is infinity. So both the sides, if your rejection region comes, it is called as two-tailed test. And when will this both the side rejection region come? Only if you are doing not equal to sums. Only if you are doing not equal to sums. See your students, in this way you have to draw a normal curve and there is a critical value here. Okay, there is a critical value here. 1 minute. Okay, there is a critical value here. This value, this line, first line here and first line here, these are your critical values. Beyond that values, whatever values are there, those are called rejection values. Okay, and that region is called rejection region. The region in the middle is called as acceptance region. So this is two-tail. Both the sides, both the tails or both the sides of the normal curve are there. When is this happening? When the alternate hypothesis is not equal to, when your H1 is not equal to. And what is one tail, sir? One tail means, students, rejection region comes either on the right side only or on the left side only. Only on one particular side it comes. Sir, how will we know whether it is left side or right side? It will be right side, students. It will be right side here if it is a sum of more than, greater than, larger than, right side. If the sum is about less than, smaller than, then it is left side. So one tail test is where the rejection region is located at one tail only. Either it is less than or it is more than. Only then we consider it is left or right. If it is less than, it is left, lower tailed. If it is right, okay, greater than, then it is right. It is called as upper tail. Okay, but it is one tail. See here, if it is left side, then only one left tail test, this side. If it is right side, then only this side. When is left side, students? When it is smaller than or less than. Okay, when is it right side? When it is greater than or more than sums. Next, null distribution. Null distribution is nothing but, students, distribution under the null hypothesis. Okay, whatever distribution is there under the null hypothesis is called as null distribution. That is whatever sum that we take to do. Test statistic, we have already known this. What is test statistic? Sir, whatever data from the sample we are taking, okay, on whose distribution we are testing this entire data, no, that is called as the test statistic. Whatever data we are testing, okay, with the particular value, that particular value of the sample is called as the test statistic, which is used for hypothesis. So students, that's it from this particular chapter. Okay, that's it from this particular chapter of theory. This was the entire theory which was there in this particular chapter, students. We have a few small questions here, okay, not big questions. We have a few small questions here, students. Here no questions at all. Okay, so these small questions are there, no? Let us finish it right here, right now, these small questions. Okay, they will ask you direct questions, students. Okay, direct questions they will ask you. Up to here we have questions, no? Let me zoom out a little bit. Now you can see all the questions. They might ask you any question, students. Here let me do it using paint. Okay, okay, see here, students, first question, question number 10. See this question. Write the formula of standard error of x bar 1 minus x bar 2. X bar 1 minus x bar 2 is what, students? Is it mean or difference of means? Is it mean or difference of means?
Difference of means.
Difference of means, sir. What is the formula, students? Difference of means. What is the formula?
Square root of sigma 1.
Sir, SE equals to square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. Very simple. That's it. That's it, students. So simple answer. Okay, let's do this 11th one, students. What is this 11th one? Size of two samples is given 50 and 100. Population standard deviation are 20 and 10. Compute SE. Sir, same formula, no sir, once again. Yes, students, same formula. Only thing is you have to substitute. So students, I will not write the formula again. I will not write the formula again. But in the same formula, just substitute, students. Samples, sir, n1 is 50, n2 is 100. n1 is 50, n2 is 100. Sigma 1 is 20, sigma 2 is 10. Simplify and tell me the answer, students. Square root of 20 square by 50 minus 10 square by 100. Tell me the answer. Sorry, not minus, plus, plus, plus. So sorry, plus. Same formula as above.
It's 3.
3, sir. You're getting square root of 8 plus 1, right? You're getting square root of 8 plus 1.
Yes, sir.
Yeah,
Yes, sir.
that's square root of 9, which is 3. Very good. Okay, very good. Next
Should we
student.
ignore?
Yeah,
We'll ignore the minus 3, right?
where are you getting minus?
The square root of 9 can be.
Oh, okay, okay. Oh, you're asking me like that. Okay, okay. Yeah, yeah, yeah. Obviously,
Yes.
we take only the positive values. Yes. Okay. Let's do the 14th sum, students. 14th sum directly. 14th one. P is 0.5. N is 100. What is SC of P? Sir, SC of P formula first of all. What is the formula, students? SC of P. Anybody? Square root.
Square root of PQ over N.
Very good. PQ divided by N, sir. Square root of P is 0.5, sir. That means Q also will be 0.5. So it is 0.5 into 0.5 divided by 100. And then take the square root of it. How much is the answer, Suzanne?
0.05, sir.
0.05.
5.
Yes, that's correct. 0.05 is the answer. Very good. That's correct. Okay. Okay. Next. 15th one is easy. Okay, write the formula for P1 minus P2 when P1 is not equal to P2. When they are not equal. When they are not equal, what's the formula, students? Sir, square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2. That's the formula. And 17th one is also easy, students. When P1 and P2 and P are equal, what's the formula? So the formula is, for 17th one, students, so the formula is square root of P into Q into 1 by N1 plus 1 by N2. Very simple. That means it remains as only with one question, students. Question number 16. A lot contains 2% defective items. Okay, let me write that. Oh, wait a minute. 2% defective items out of 40. And one more lot contains 1% defective items out of 60. What we have to find? We have to find E P minus 1, P1 minus P2 and SC also. Okay, we have to find the estimate also and the standard error also. Okay, we have to find the expected value also, P1 minus P2, and this one standard error also of P1 minus P2. Okay, but first, students, let us write what this 40 and 60 is. Students, what is this 40 and 60? 40 and 60?
Isn't it capital P and wait, no.
No, 40 and 60. Big numbers.
N1,
Yes, N1 and
N1
N2.
and N2.
Yes, very good. This is N1 and N2, sir. What about this 2% and 1%? Sir, 2% is for the first items. That means this proportion, sir. They have given proportion, capital P1. And this one is capital P2, sir. 2% means how much, students? 2% in the sense
0.02.
0.02, and this is 0.01. So students, how much is, what is the first question? E of P1 minus P2. How much is this answer? E of P1 minus P2. Very easy. Sir, capital P1 minus capital P2, sir. Can you tell me the answer, students?
So 0.01.
0.01, sir. Such a simple answer. 0.02 minus 0.01 is nothing but 0.01 itself. That's what is the answer given here. 0.01. That's what is the answer given here. Standard error. How to find out standard error? They have given the answer 0.0256. But are we getting the same? Let us check. Standard error formula. Are P1 and P2 same, students? No, sir. Different answer. So the formula is P1Q1 divided by N1 plus P2Q2 divided by N2. Be very careful. Sir, P1 is 0.02 into, how much is Q, students? Q1, how much is Q1?
0.98.
Very good. 0.98, sir. Divided by 40 plus 0.01 into 0.99 divided by 60. How much is the final answer, students? Are you getting 0.0256? Please check. Square root of 0.02 into 0.98 divided by 40. Susan, tell me the first part, how much are you getting? 0.02 into 0.98 divided by 40.
I got 0.00049, sir.
Correct. Okay, 0.00049. Very good. Even I got that. Diksha, tell me the second answer. 0.01 into 0.99 divided by 60.
So it's 0.000165.
Very good. Correct. 0.000165. Nikita, total of this?
Sir, 0.000655.
Okay, 0.000655.
655.
Okay. 655. Do the square root, students. Are you getting the final answer?
Yes, sir.
Yes, 0.02559 you are getting, and they have written it here as 0.0256. Okay, that's it with this particular chapter, and rest everything is nothing but theory, students. Rest everything is theory in this chapter, which you should study on your own, and I have given you the notes already of this. And next class we will start with large sample test. Okay, students, so we will wind up here. Until then, take care, everybody. See you in the next class. Bye bye, students.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Yeah.